In the late summer of 1942, the Luftwaffe's senior intelligence officers were circulating a report. It was, by all accounts, a confident document. Its central conclusion was simple. The Americans had sent a bomber to the European theater that the Reich's fighter pilots could dismantle at will. The aircraft in question was the Boeing B-17 Flying Fortress. And in those early months, before the escort fighters arrived, before the formation tactics were hardened through blood and wreckage over France and Germany, the men who flew her were dying at a rate that gave even her most ardent defenders pause. The Luftwaffe read those loss numbers with satisfaction. They watched the ragged, smoke-trailing formations limping back to England, and they did the math they understood. What they failed to do was run the other set of numbers, the ones the enemy was already running. And that failure, that specific, catastrophic failure of strategic auditing, would cost the Third Reich a war. This is not a story about heroism, though there is plenty of it. This is a forensic examination of a machine, a doctrine, and an industrial logic so overwhelming that by the time the enemy grasped its full weight, there was nothing left for them to do but absorb it. The B-17 Flying Fortress was not a perfect aircraft. It was not the fastest, not the most maneuverable, not the most comfortable platform ever bolted together in a factory. What it was, with cold geometric precision, was a weapons system specifically engineered to survive punishment that would have destroyed anything else flying in 1942, and to return fire with a ferocity that the Jagdwaffe simply had not been designed to respect. They would learn to respect it. The lesson was non-negotiable, and the tuition was paid in pilots. To understand the kinetic reality of what the B-17 represented, you have to go back to the doctrine first. By the mid-1930s, the United States Army Air Corps had made a strategic bet. They believed that a sufficiently armed, sufficiently rugged heavy bomber could penetrate defended airspace in daylight, bomb with precision, and defend itself well enough to make the exchange rate prohibitive for any intercepting force. That bet required a specific aircraft. Boeing's answer was a four-engine, all-metal monoplane with a design philosophy that would have seemed almost irrational to a budget-minded planner. The B-17 was over-engineered in the most deliberate sense of that term. Its airframe was built to absorb structural damage that would have torn apart contemporary European counterparts. Its fuel system incorporated self-sealing tanks. Its crew of 10 operated in an environment studded with .50 caliber M2 Browning machine guns, eventually as many as 13 in the G model variant, positioned to cover virtually every angular approach a fighter pilot might attempt. The .50 caliber Browning was not incidental to this calculus. It was the ballistic anchor of the entire defensive doctrine. With an effective range of approximately 1,800 yards and a muzzle velocity of 2,910 feet per second, it could reach out and engage a Bf-109 or a Focke-Wulf 190 at distances that gave the German pilot a serious, specific problem. He could not simply bore in from distance and walk his cannon rounds onto the fuselage the way he might against a Lancaster at night. He had to close, and closing meant entering a cone of intersecting fire that the B-17's gun positions were geometrically arranged to generate. This was not an accident. This was engineering as strategic intent, the mechanical embodiment of a doctrine that said, "Come and get us, and we will make you pay a price you cannot afford at scale." By the first week of January 1943, the men running production logistics at Boeing's Plant 2 facility in Seattle were operating on a schedule that had no peacetime equivalent. The factory floor, over 1 million square feet of it, camouflaged from above with a false suburban rooftop built to deceive Japanese reconnaissance aircraft that never came, was turning out B-17s at a rate the Luftwaffe's strategic planners had not modeled for, because modeling for it would have required them to confront an industrial reality too uncomfortable to fully absorb. At peak wartime output, American factories were completing a new B-17 roughly 300 working hours. Not months, hours. When you fold in the consolidated B-24 Liberator lines running simultaneously in Fort Worth and San Diego and Willow Run, Michigan, the aggregate heavy bomber production figure for the United States in 1944 alone reaches approximately 35,000 aircraft of all heavy types. Germany, in that same year, under Albert Speer's most aggressive rationalization of the armaments economy, produced fewer than 2,000 heavy bombers total, and most of those were Heinkel HE-177s, plagued by engine fires so persistent the crews had nicknamed the aircraft the Flying Lighter. This is where the strategic audit becomes an almost clinical exercise. The Luftwaffe was not simply fighting an air force, it was fighting an industrial metabolism. Every B-17 it shot down over Schweinfurt or Regensburg was replaced, in mathematical terms, before the smoke had cleared from the wreckage. The American system did not grieve production losses the way a rationed economy grieves them. It absorbed them, cataloged them, and accelerated. The logistical lung of the American war machine had a capacity that no Axis planner had correctly measured, and by the time they began to appreciate the true dimensions of it, the exchange rate had already turned lethally against them. Consider the specific arithmetic of the Schweinfurt raids. The two missions in August and October of 1943 that have since become the most forensically examined engagements of the entire strategic bombing campaign. On the second Schweinfurt mission, October 14, 1943, Black Thursday, as the 8th Air Force would remember it, the Americans lost 60 B-17s out of 291 dispatched. A 20.6% loss rate in a single mission. By any conventional operational standard, that number represents a crisis. The post-war mythology, particularly the German side of it, tends to linger on that figure as evidence that the unescorted daylight bombing doctrine had been broken. And tactically, in that narrow window, they were not wrong. The cost was unsustainable if repeated at that frequency. But here's the ballistic anomaly in that narrative, the detail that gets quietly omitted when the story is told from the perspective of the Jagdwaffe's triumph. On that same mission, the B-17 formations claimed approximately 186 German fighter kills. The actual confirmed figure, when post-war records from both sides were reconciled, was lower, as is always the case when gunners in combat are cross-claiming targets through the adrenaline and the cordite smoke. But even the conservative accounting puts German fighter losses on that day at somewhere between 35 and 38 aircraft destroyed, with a substantial number of additional damaged aircraft that never flew again. And critically, those were pilots, experienced, trained, irreplaceable pilots, men who had been flying since Spain, since Poland, since the Battle of Britain. Germany could not manufacture those men on a factory floor. They had no Boeing Plant 2 equivalent for Jagdwaffe veterans. The B-17's defensive armament was doing something that transcended its mechanical function. It was conducting attrition on a resource, experienced fighter pilot hours, that the Luftwaffe had no industrial answer for. By mid-1944, the average Jagdwaffe pilot arriving at a frontline unit had fewer than 150 hours of total flight time. His American adversary in the bomber stream, the man behind the .50 caliber Browning in the ball turret or the tail position, had likely completed a full combat tour or was operating alongside crews who had. The experience gradient had inverted. The weapon that German intelligence had dismissed as insufficient, too slow to evade, too large to miss, too American in its blunt mechanical philosophy to be truly dangerous, had quietly bankrupted the one asset Germany could not replenish. There is a specific engagement that crystallizes this dynamic with a precision that no aggregate statistic can quite replicate. In May of 1943, a single B-17F named All-American, already famous within the 8th Air Force for having survived a mid-air collision with a German fighter over Tunisia that left her tail section held together by a strip of fuselage skin no thicker than a man's hand, exemplified the kinetic philosophy the airframe had been built around. But it is the lesser-known engagements, the statistical midpoints of the campaign rather than its celebrated outliers, that tell the truest story. Crews flying their 8th, 9th, 10th missions over occupied Europe were regularly filing gun camera assessments and combat reports documenting 3, 4, 5 confirmed fighter engagements per sortie. Multiplied across a formation of 200 aircraft, each with up to 13 gun positions, the volume of defensive fire the Luftwaffe was flying into was not a gauntlet, it was a geometry problem with no survivable solution at scale. The Jagdwaffe's own internal assessments from late 1943 and early 1944 reflect this dawning comprehension in language that is, for military bureaucratic documents, unusually candid. Fighter commanders were noting that their pilots were refusing, not openly, not in ways that invited courts-martials, but in the specific way that men under impossible pressure find technical reasons to abort sorties, to misidentify targets, to arrive late to intercept vectors. The machine that had been mocked in intelligence briefings for its lumbering size and its ungainly silhouette was producing, mission by mission, a psychological erosion inside the Jagdwaffe that no replacement aircraft program could address. You cannot fix a morale problem with a new airframe when the morale problem is a correct tactical assessment of the mathematics. In the early weeks of February 1944, the operation that the 8th Air Force's planners had designated with the almost bureaucratically understated codename Argument began to reshape the strategic map of the European air war in ways that would not be fully legible until the post-war accounting was complete. What history would come to call Big Week, 6 days of sustained heavy bomber operations against the German aircraft industry itself, was not the turning point because of the tonnage dropped or the factories damaged, though both figures were significant. It was the turning point because of what arrived alongside the bombers. The North American P-51 Mustang, fitted with the Rolls-Royce Merlin engine and carrying drop tanks that extended its combat radius to the German border and beyond, had entered the theater in sufficient numbers to change the fundamental equation. The B-17 had been fighting a defensive war inside the bomber stream for 18 months. Now, for the first time, the Jagdwache had to fight a two-front kinetic reality simultaneously, the bristling defensive geometry of the bomber formation and a long-range escort fighter that could meet them on equal terms at altitude and pursue them back to their own airfields. But here is what that narrative obscures if you accept it too cleanly. The P-51 did not rescue the B-17. It completed what the B-17 had already begun. The Mustang arrived into an interceptor force that had already been ground down by 18 months of attrition against 50 caliber defensive fire. It arrived into a Jagdwaffe whose experienced pilot pool had been so severely depleted by the exchange rates of 1943 that the men climbing into the BF-109s and FW-190s to meet it were, by the cruel logic of the situation, already at a measurable disadvantage before the first trigger was pulled. The B-17 had been running the long, unglamorous, statistically brutal first phase of that audit since the summer of 1942. The Mustang closed the ledger. The Flying Fortress had been writing the entries for 2 years. The psychological dimension of this collapse deserves its own forensic attention because it operated on a timeline that ran parallel to the mechanical one and is, if anything, more revealing of the strategic miscalculation that the Luftwaffe had committed at the outset. German fighter pilots in the summer of 1942 had watched the early B-17 formations and drawn reasonable conclusions from what they saw. The aircraft was large, relatively slow at combat altitude. Its maximum speed of 287 miles per hour at 25,000 feet was not going to win any tactical foot races, and it arrived in numbers that, in that early phase, were manageable. What the assessments missed, because the data did not yet exist to support a different conclusion, was the compounding nature of the industrial logic behind the aircraft. Every B-17 that German fighters destroyed was followed by 2 more. Every pilot they lost to defensive gunfire was followed by silence. The replacement pipeline on the American side was a logistical river. On the German side, it was a narrowing creek with an identifiable endpoint. There is a particular kind of delayed realization that military historians encounter in the primary sources of losing powers, a moment when the internal documents shift register, when the confident analytical tone of early war intelligence assessments gives way to something that reads more like a man doing arithmetic he already knows the answer to, but cannot stop himself from checking again. In the Luftwaffe's case, that register shift is visible in the fighter command assessments from late 1943. The language becomes more qualified. The loss projections become more candid. The requests for production increases become more urgent and simultaneously more detached from any realistic industrial capacity to fulfill them. The bomber they had called a toy, and some had, in the comfortable early months used exactly that register of dismissal, had turned out to be something closer to a siege engine. Slow, yes. Relentless, absolutely. Built not for elegance, but for the specific, grinding, industrially supported work of breaking an adversary's capacity to resist. The men who flew the B-17 understood this in the way that men understand things that are happening to their bodies rather than to their theories. They understood it in the oxygen masks at 30,000 feet, where the temperature ran to minus 60 degrees Fahrenheit, and the frostbite arrived before the fighters did. They understood it in the ball turret, that plexiglass sphere suspended beneath the fuselage with room for exactly one man in a posture that left no room for dignity, where a gunner would rotate and track and fire and hope that the mathematics of his field of fire and the mathematics of the incoming attack would resolve in his favor. They understood it in the moment after landfall on the return leg, when the coast of England appeared below and the crew chief met the aircraft on the hard stand and counted the holes and calculated what would need to be replaced before the next mission, which was already scheduled. That endurance, that specific, mechanical, unglamorous American endurance is the true legacy of the B-17 and the industrial architecture that produced it. It was not built in a single dramatic stroke of engineering genius, though the engineering was genuinely exceptional. It was built in the accumulated hours of factory workers in Seattle and Wichita and Burbank, in the procurement chains that moved aluminum from processing plants to assembly lines with a logistical precision the world had never seen at that scale. In the training pipelines at bases across the American Southwest that were producing crews faster than the Luftwaffe could produce the pilots to oppose them. The strategic audit of the B-17's contribution to the defeat of Nazi Germany does not resolve into a single decisive engagement or a single dramatic number. It resolves into a ratio. The ratio between what America could produce and absorb and replace and what Germany could not. That ratio was never close. The enemy simply took longer than they should have to read it correctly. When the last B-17G rolled off the Boeing line in April of 1945, 12,731 of them had been built. They had dropped approximately 640,000 tons of bombs over Europe. They had absorbed losses that would have halted any less supported campaign and kept flying. The aircraft that German intelligence once categorized as tactically manageable had, by the final accounting, helped dismantle the industrial and military infrastructure of the most heavily defended airspace in the history of aerial warfare. Not because it was perfect, not because it was fast or elegant or easy to fly in the cold, thin air over Germany, but because it was built by a nation that had correctly understood the one variable its enemies consistently failed to model. That American industrial capacity, once fully mobilized, did not plateau. It accelerated. And by the time the Jagdwaffe's planners finally ran the correct set of numbers, there were no moves left on the board that could change the answer. The math was always there. They just refused to believe it until the sky made it undeniable.